Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. So today we are starting exercise 3.3. To solve the example from this exercise, you should have to know all the result related with inverse trigonometric function. So we have seen when a function is called as inverse trigonometric function, what is its domain, what is its range, and even we have proved 16 properties related with what? Inverse trigonometric function. If all these results are known to you, then and then only you are able to solve the examples from this exercise. So prepare the list of all these formulas, and using these formulas and these properties we will solve the example. See, in the first example we have to find out principal values of given inverse trigonometric function, and when we can say that the value is principal value if it satisfies the given inverse trigonometric function and lies in the range of that inverse trigonometric function. So here all range of all the inverse trigonometric functions are shown in the table. So already we have proved this result, isn't it? So now let us try to solve the first example. The method which you are using to solve the first example, exactly same method is used in all the example. See, the first example, whatever may be the inverse trigonometric function is given to us, denote it by say here I am denoting it by theta. So you are able to denote it by x, y, or by any variable alpha, beta, gamma also. So denote this inverse trigonometric function by theta. So I am supposing that let theta is equal to sine inverse of 1 by 2. Now solving this, we are trying to find out such value of theta which satisfies this inverse trigonometric function and lies in its principal. It's in range, then and then only we will call it as what? Principal value. So let us simplify, take sine on both side. If we are taking sine on left hand side, on this side we will get sine theta. On this side if we are taking sine and sine inverse will get cancelled, we will get 1 by 2. Now sine theta is equals to 1 by 2 is nothing but value of sine what? Sine pi by 6, sine 30. Now comparing both side, we can say that theta is equal to, this implies that theta is equal to what? Pi by 6. That is, theta means what? Theta means what? Sine inverse of 1 by 2. So sine inverse of 1 by 2. What value of sine inverse of 1 by 2 you have got here? Pi by 6. Now check whether this value lies in the domain or not. Yes, pi by 6 is the value of what? Lies in between minus 90 to plus 90. Somewhere it will lies in the first quadrant. So which belongs to minus pi by 2 to plus pi by 2. And since this value of sine inverse lies in the principal, lies in the range of sine inverse, that's why we can say that it is what? Principal value. So therefore principal value of which inverse trigonometric function? Sine inverse of what? 1 by 2 is how much? Is pi by 6. In this way we are solving the example. So let us try to solve the second example. In the second example we are finding the value of what? Cosec inverse. So let us denote it by theta, and we are finding the value of what? Principal value of cosec inverse of 2. So again taking cosec on both sides, so on this side we will get cosec theta, and on the right hand side remaining term is what? 2, because if you are taking cosec and cosec inverse will get cancelled. Keep this cosec theta as it is. 2 is nothing but value of what? Cosec 30. 30 means what? Pi by 6. Now comparing both sides, here also we can say that theta is equal to what? Pi by 6. But theta means what? Theta means what? Cosec inverse. Cosec inverse of 2 is equal to pi by 6. Now check whether this value pi by 6 belongs to range or not. What is the range of cosec? Minus pi by 2 to plus pi by 2, and yes, it belongs to this interval minus pi by 2 to plus pi by 2. Difference what? 0. So since it belongs to the range, that's why we can say that it is principal value. So therefore principal value of cosec inverse of 2 is how much? Pi by 6. So now let us try to solve the third example. So in this third example given the inverse, denote the given inverse trigonometric function by theta. What is the value of theta here? Tan inverse of -1. So here negative number is there. So in such cases, see how to solve the example. So first take tan on both sides. So on this side we will get tan theta, and on this side we will get -1, because if we are taking tan, tan and tan inverse will get cancelled according to our property. So tan theta, keep it as it is. Now theta is nothing but what? Principal value of which inverse trigonometric function? Tan inverse. Its range is in between what? -pi/2 to +pi/2. -pi/2 to +pi/2 means which two quadrant? First and fourth quadrant. So here we can observe that value of tan is negative, means definitely it does not appear in what? First quadrant, means definitely here value appears in what? Fourth quadrant. Fourth quadrant means here don't say that it is in between what? 3pi/2 to 2pi. Now in inverse trigonometric function, consider fourth quadrant means 0 to -pi/2. Getting it? So well, minus, keep it as it is. Can I write 1 as tan pi/4? Tan 45. Minus, keep it as it is. 1 is the value of tan 45. Minus tan theta, can I write it as tan minus theta? Tan minus theta. Tan minus pi/4 is minus tan pi/4. Keep this side as it is, tan theta as it is. Comparing both sides, what is our conclusion? Theta is equal to minus pi/4. That is theta. Theta means what? Tan inverse of -1. Tan inverse of -1 is equals to how much? Minus pi/4. So since this is the value of tan inverse, we have to check that it lies in range or not. Yes, it lies in what? Range. It means in between minus pi/2 to plus pi/2. Minus pi/4 somewhere lies in between what? 0 to minus pi/2 means in fourth quadrant. So this value belongs to minus pi/2 to plus pi/2, and since it lies in the range of this inverse trigonometric function, so we can say that it is the principal value. So therefore principal value of tan inverse of -1 is how much? Minus pi/4. Now let us try to solve the fourth example. In the fourth example, let us denote the given inverse trigonometric function, say by theta. So here theta is equal to tan inverse of -1/√3. So again use the same method, taking tan on both sides. So on this side we will get tan theta, on this side we will get -1/√3. So on this side, minus, keep it as it is. 1/√3 is the value of tan pi/6, means tan 30. So which is equals to, again minus tan theta can be written as what? Tan minus theta, because here value of tan is negative, means definitely it does not lies in first quadrant, means it lies in what? Fourth quadrant. So comparing both sides, we can say that this implies that theta is equal to how much? Minus pi/6. But theta means what? Theta means tan inverse. So tan inverse of -1/√3 is equals to minus pi/6, and check whether this is the value of what? Tan inverse, and it lies in our range. Which range? Minus pi/2 to plus pi/2, which is the range set of what? Tan inverse. Since it lies in the range set, so we can say that this is what? Principal value. So therefore principal value of tan inverse of -1/√3 is how much? Is minus pi/6. In this way we have got the principal value of this inverse trigonometric function. Let us try to solve the last two examples. See, in the example number 5th, given inverse trigonometric function is tan inverse of 1/√2. We have denoted it by theta, taking sine inverse of 1/√2, taking sine on both sides. So here we will get sine theta. On this side, sine and sine inverse will get cancelled. Remaining term is 1/√2. So sine theta, keep it as it is. We know that 1/√2 is the value of what? Sine 45, means sine pi/4. Comparing both sides, we can say that theta will be equals to pi/4. So that is, theta is nothing but what? Theta is sine inverse of 1/√2. On this side, pi/4, keep it as it is. Now what we can observe here, this pi/4 belongs to a range of sine inverse or not. What is the range here? Minus pi by 2 to plus pi by 2, and yes, it lies in between in the first quadrant, and first quadrant is the part of what? Range set. So that's why we can say that this value belongs to range, means we can say that it is the principal value. So therefore principal value of sine inverse of 1 by root 2 is how much? Is pi by 4. Lastly, let us try to find out principal value of cos inverse of minus 1 by 2. Again, I am denoting it by theta is equal to cos inverse of minus 1 by 2. Again, taking cos on both sides, so take on this side will get cos theta, on this side cos and cos inverse will get cancelled, remaining term is minus 1 by 2. Keep this minus as it is. 1 by 2 is the value of what? Cos pi by 3, means cos 60. Cos 60 is how much? 1 by 2. Now here value of cos is negative, and its principal value lies in which interval? 0 to pi. 0 to pi means in first and second quadrant, but here value of cos is negative, means definitely it does not lies in which? First quadrant, means definitely it lies in what? Second quadrant. Second quadrant means what? Pi minus theta, isn't it? So now using allied angle formulas, so to find out value in second quadrant, this minus cos theta can be written as cos pi minus theta. What is theta here? Pi by 3. Now again observe here, we know that cos pi minus theta is minus cos theta. So minus cos theta can be written as cos pi minus theta, because we know that its principal value lies in what? Second quadrant. So simplified, cos, keep it as it is, take the cross multiplication, 3 pi minus pi will be equals to 2 pi by 3. On this side cos theta, keep it as it is. So comparing both sides, we can say that theta is equal to 2 pi by 3. But theta means what? Theta is nothing but cos inverse of minus 1 by 2. On this side 2 pi by 3, keep it as it is, and we can observe that this value belongs to which interval? 0 to pi. That's why we can say that it is the principal solution of this inverse trigonometric function. So therefore principal value of cos inverse of minus 1 by 2 is how much? 2 pi by 3. In this way we have got the principal value. So hope the method to solve such type of example is very clear to you. So very easy method is there, but you should have to know the range of every inverse trigonometric function to find out what? Principal values. Now we are starting question number 2 from this exercise. So in this question number 2, some inverse trigonometric expressions are given to us, and question is to evaluate. Evaluate means to find out the values. Some example orally also we are able to solve it. See the first example. What is the value of tan inverse of 1? Pi by 4. Means we know that 1 is the value of tan if for what? 45 degree, means pi by 4. Cos inverse of 1 by 2 is what? 60 degree, means pi by 3. Sin inverse of 1 by 2 means what? 30 degree, means pi by 6. So this method orally also, since we are able to find out these values orally also, but this method we are able to apply in case of objective type question. As per as board is concerned, board required what? Solution step by step. So try to understand the steps which we have to use while in case of board exam. Okay, so now here first we have to find out value of tan inverse of 1. So let us denote that value, say by alpha. That alpha is equals to tan inverse of 1. So therefore taking tan on both sides, so tan alpha is equal to, on this side tan and tan inverse will get cancelled, will get 1. So therefore tan alpha is equals to, now 1 means what? Tan pi by 4. Tan pi by 4 means 45. So therefore alpha is equals to Comparing both side, we can say that alpha is equal to pi by 4. And can I say that alpha means what? Tan inverse of 1. And what is the value of tan inverse of 1? Pi by 4. We have to check whether this value lies in the range or not. So what is the range of tan inverse? It will be minus pi by 2 to plus pi by 2. And yes, this value lies in this range. That's why we are able to consider it as what? Principal value. So let us denote it by equation number first. Now we are finding our second required value. What is the second required value? Cos inverse of 1 by 2. So here let beta is equal to cos inverse of 1 by 2. Taking cos on both sides, so here on this side we will get cos beta, on this side remaining part is 1 by 2 if we are taking cos on both sides. So therefore cos beta, keep it as it is, 1 by 2 is the value of cos 60 degree, means pi by 3. Again here comparing both sides, we can say that beta is equal to pi by 3, and pi by 3 belongs to range of what? Cos inverse. Its range is what? 0 to pi. So let us denote it by equation number 2. In this way we have got second required value beta. Beta means what? Cos inverse of 1 by 2. Lastly, let us try to find out value of sin inverse of 1 by 2. Now I am denoting here. So now let gamma is equals to what? Sin inverse of 1 by 2. So taking sin on both sides, we will get sin gamma is equals to 1 by 2. Sin gamma is equal to 1 by 2. If we are taking sin on this side, sin and sin inverse will get cancelled, remaining term is 1 by 2. So therefore keep left hand side as it is, sin gamma as it is. 1 by 2 is nothing but value of what? Sin 30. 30 can be written as what? Pi by 6. Comparing both sides, we can say that gamma is equal to pi by 6, and pi by 6 belongs to what? Minus pi by 2 to plus pi by 2, means it belongs to range of sin inverse. So minus pi by 2 to plus pi by 2. In this way we have got our third required value denoted by equation number 3. Now we are finding the value of this expression. So therefore tan inverse of 1 plus cos inverse of 1 by 2 plus sin inverse of 1 by 2, sin inverse of 1 by 2 is equals to tan inverse of 1 can be replaced by its value. What is the value of tan inverse of 1? Its value, tan inverse of 1 we have denoted by what? Alpha. Cos inverse of 1 by 2 we have denoted by what? Beta. And sin inverse of 1 by 2 we have denoted by what? Gamma. So which is equal to alpha I am replacing by its value pi by 4. So replace it by its value pi by 4 plus beta can be replaced by its value pi by 3. So pi by 3 plus, and gamma can be replaced by its value pi by 6. All these values we are substituting from equation first, second and third. Okay, so which is equal to, now what is the LCM of denominator? 3, 4 and 6 is what? 12. To get 12 in the denominator, we have to multiply to denominator by 3. So multiply to numerator also by 3. To get 12 in the denominator, we have to multiply to denominator by 4. So multiply to numerator also by 4. Here to get 12, multiply by 2. So that's why we are multiplying to numerator by 2. So in this way, we have got the solution. Just remaining part is to simplify it. 4 plus 2 is what? 6. 6 plus 3 is what? 9. 9 pi divided by 12. Both the numbers are divisible by what? 3. So if we are dividing to numerator and denominator by 3, so here we will get 3 pi upon 4. Just simply divide to numerator by 3 and denominator by 3. In this way we will get the addition of these three inverse trigonometric function. In this example, even cos inverse of 1 by 2 plus sin inverse of 1 by 2, you are able to replace it by what? Pi by 2 according to our one property. तो फिर ये जो दो वैल्यूज है ये फाइंड करने की आपको जरूरत नहीं है, बिकॉज वी हैव वन प्रॉपर्टी दैट साइन इनवर्स ऑफ एक्स प्लस कॉस इनवर्स ऑफ एक्स इज व्हाट? पाई बाय 2. चेक दैट. व्हाट इज एक्स हियर? 1 by 2. Here also x is what? 1 by 2. Since same values are there, directly you are able to substitute the value of this expression is equal to what? Pi by 2. Even we can observe that sum of these two term is also what? Pi by 2. So again example will become simple. लेकिन अभी मैंने हर एक एग्जाम्पल के हिसाब से पूरे स्टेप steps लिख के दिए, you are able to apply the property in this example also. Means only you have to find out value of what? Tan inverse. यहाँ तक का parts ये complete कीजिए. Don't find these two values because in these two cases you are able to apply the property. Which property? That cos inverse of x plus sin inverse of x is equal to what? Pi by 2. इस ये दोनों की एडिशन डायरेक्टली pi by 2 रखिए और sin inverse of 1 is what? Pi by 4. Simplifying it, you will get the same answer. Getting it? One short method is available in this example. Now see the second example. In this second example, we have to find out value of what? Cos inverse of 1 by 2 plus twice sin inverse of 1 by 2. So here we have considered this expression. Cos inverse of 1 by 2, keep it as it is. Twice sin inverse of 1 by 2 can be written as sin inverse of 1 by 2 plus sin inverse of 1 by 2. Now according to our property, sin inverse of x plus cos inverse of x can be replaced by what? Pi by 2 according to one of our property. Give here reason that since sin inverse of x plus cos inverse of x will be equals to what? Pi by 2. We have already proved this property. Now sum of these two terms is known to us. Only the remaining part is to find out value of what? Sin inverse of 1 by 2. So if you are making the use of this property, example will become simple. So let us suppose that sin inverse of this 1 by 2 will be equals to alpha. So therefore sin alpha is equals to what? 1 by 2. So therefore sin alpha is equals to 1 by 2 is nothing but value of what? Sin 30 means what? Pi by 6. Comparing both sides, we can say that alpha is equal to, what is the value of alpha? Comparing both sides, pi by 6. Alpha means what? Sin inverse of 1 by 2. Means it is the value of sin inverse of 1 by 2. Check whether it lies in range or not. Yes, it lies in between minus pi by 2 to plus pi by 2. That's why we are able to consider it as what? Principal value. Now remaining part is just to substitute the values. Sum of these two terms is equal to pi by 2 according to this property plus sin inverse of 1 by 2. Sin inverse of 1 by 2 we have denoted by what? Alpha. So which is equal to 1 by 2, keep it as it is. Now we are substituting the value of alpha. What is the value of alpha? From equation number first, its value will be equals to what? Pi by 6. So this value we are substituting from equation number first. Lastly, let us try to find out their addition. So here, what is the LCM of denominator? 6. To get 6 here, we have to multiply by 3. So that's why we are multiplying to numerator also by 3. 3 pi plus pi will be equals to 4 pi. 4 pi upon 6. Both the number are divisible by what? 2. If I am dividing to numerator and denominator by 2, so we will get 2 pi upon 3. So will be the value of this inverse trigonometric expression. See, in the third example, we have to find out difference of these two inverse trigonometric function. So first find out the value of first function. Let us denote it by alpha. So what is that function? Tan inverse of root 3. So taking tan on both sides, so we will get tan alpha is equals to root 3. So therefore tan alpha, keep it as it is. Root 3 is the value of what? Tan 60. 60 means what? Pi by 3. Comparing both sides, we can say that alpha is equals to pi by 3, and this pi by 3 belongs to what? Range of tan inverse, means in between minus pi by 2 to plus pi by 2. Now let us denote the second value, say by beta. And let beta is equal to sec inverse of minus 2. Now again, if we are taking sec on both sides, so on this side we will get sec beta, and on this side sec and sec inverse will get cancelled, remaining part is minus 2. Adjacent value of sec is negative, means definitely it lies in what? Second quadrant, because its range is in between 0 to pi. So which is equals to minus, keep it as it is. Can I replace 2 by sec 60. 60 means what? Pi by 3, because 2 is the value of what? Sec 60. So which is equal to, now according to allied angle formula, minus sec theta can be written as sec pi minus theta. What is theta here? Pi by 3, because sec pi minus theta is minus sec theta. Let us simplify it, which is equal to sec. Now if we are taking cross multiplication, 3 pi minus pi will be equals to 2 pi by 3. Now if we are comparing both sides, so this implies that beta is equal to, what is the value of beta? 2 pi by 3. Check that this value belongs to what? 0 to pi. Difference what? Difference pi by 2. So since the value lies in what? Range set, so we are able to consider it as what? Principal value. Now since both the values are known to us, remaining part is just to substitute these values in this expression. Tan inverse of root 3 we have denoted by alpha, and sec inverse of minus 2 we have denoted it by what? Beta. Now substitute the value of alpha. Alpha is equal to pi by 3 and beta is equals to how much? 2 pi by 3. So pi by 3 minus 2 pi by 3, since denominators are same, so take the difference of numerator. Pi minus 2 pi will be equals to minus pi. Minus pi by 3 will be the difference of these two inverse trigonometric functions. See, in this example, in question number 4, so we have to find out addition of this inverse trigonometric function. So first find out the values of this inverse trigonometric function. Denote the value of first inverse trigonometric function by alpha. So simplifying it, let us try to find out value of alpha. Taking cosec on both sides, so on this side we will get cosec alpha, and on this side cosec and cosec inverse will get cancelled. Remaining part is minus root 2. So cosec alpha, keep it as it is. We can observe that value of cosec is what? Negative, and its range set is what? Minus pi by 2 to plus pi by 2, and cosec is positive in first quadrant, but as a stand value of cosec is negative, means definitely principal value lies in what? Fourth quadrant, means in between what? 0 to minus pi by 2. So here minus, keep it as it is, root 2 can I replace it by cosec pi by 4, cosec 45, and minus cosec theta can be written as what? Cosec minus theta, means minus pi by 4. Okay, cosec minus theta is minus cosec theta. So comparing both sides, we can say that alpha is equals to what? Minus pi by 4, and we can observe that this value lies in which interval? Lies in between minus pi by 2 to plus pi by 2. Difference what? Difference 0, means excluding 0. So since this value lies in this range set, so we are able to consider it as what? Principal value. Let us denote it by equation number first. Now we are finding our second required value, that is cot inverse of root 3, and let beta is equals to cot inverse of root 3. Now if we are taking cot on both sides, so on this side we will get cot beta, on this side cot and cot inverse will get cancelled. Remaining part is root 3. So root 3 can be replaced by what? Cot pi by 6. Comparing both sides, we can say that beta is equal to pi by 6, and this value belongs to range of what? Cot, means in between 0 to pi. So in this way we have got the value of both inverse trigonometric function. Remaining part is just to substitute this value. So this value we have denoted by what? Alpha, and this value we have denoted by what? Beta. So what is the value of alpha? We have got here minus pi by 4, and what is the value of beta? We have got here pi by 6. Let us simplify it. Check that LCM of denominator is 12. So to get 12 in the denominator, we have to multiply to numerator by 3. And here to get 12 in the denominator, multiply to numerator and denominator by what? 2. So which is equal to, now take the difference here, or take the addition, minus 3 pi plus 2 pi will be equals to minus pi upon 12. So hope the idea about how to find out addition and subtraction of inverse trigonometric function is very clear to you. In the next video, we will solve remaining example from this exercise.